This week on the Tech ONTAP podcast, preview the latest ONTAP security features with our security super friends.
Welcome to the Tech ONTAP podcast with Justin Parisi, Glenn Sizemore, and Sully the Monster.
I love NetApp.
Oh, yeah.
Hello and welcome to the Tech ONTAP podcast. My name is Justin Parisi, and I have two folks on the phone today. Nobody wanted to come into the office today but me, apparently. Hi, Glenn. Hi, Andrew.
I don't know why you always have to out where we are. It's not like the listeners can tell.
Because it's fun for me.
The magic of the space internet.
I like to give the illusion that I'm actually working. So
illusion is the right word.
Yes. See, what did I do today? I put on one of the new Tech ONTAP podcast temporary tattoos. That was a win. If you want to get some of those, they'll be at Insight. So come see us.
Yes, but you tweeted it, so you fulfilled your evangelist role.
I did. I evangelized the tattoo. At Insight, I have yet to decide whether I'm going to get one on my face or on the small of my back.
Face.
All okay. Face. There we go. More visible is what we want to go for.
Bilateral on the face.
I mean, I won't be there, so that's the highest probability of me seeing it.
That's true. Okay, we're not going to go any further than that. So this podcast is going to cover the security enhancements in ONTAP 9.3. And to do that, we brought in a couple gentlemen from the security team. I guess you're the security team, right?
Yeah, we could be a team.
Yeah?
At times
Squad.
we are.
The security squad.
Squad, yes.
Yeah.
Yep.
Security super best friends. We got Juan Mojica. He's been on the podcast before. Hi, Juan.
Hey, Justin, and everybody else.
So, Juan, if you could refresh everybody's memory of what you do here at NetApp. So,
I'm a senior product manager within ONTAP. I'm responsible for security and networking and some other stuff that you probably don't care about.
This is true. I don't care. Also in the studio with me is Dan Tulledge. Hi, Dan.
Hey, how you doing?
Super. So what do you do here at NetApp?
I'm a senior technical marketing engineer, ONTAP security, partner in crime with Mr. Mojica.
And Dan's been here less than a year, right?
I'm in my fourth month.
Yeah.
Actually.
So, and fun fact, I'm actually Dan's lab manager. So
you do a nice job.
Yeah, when I remember. So Dan's been working on some things in the lab, and I've been helping him along with that. And one of those things is multifactor authentication. So we're going to kick that off with that as a topic first.
So yeah, multifactor authentication takes on a couple incarnations in ONTAP 9.3 for command line access. It's secure shell. And it's two-factor authentication, actually, rather than multi, because it involves password, user ID password, which is a single factor, and then we add in public key, the public key encryption piece of it, where we generate the key from our SSH client, and we input that into ONTAP at that point.
Okay, so let's actually back up a second. Let's actually go on a high-level overview of what multi-factor authentication means for those who don't know what that is.
That's a good idea. I mean, the one thing, it's single-factor authentication is what we're all accustomed to, right? Which is user ID and password. And what we're talking about here is authentication for administrative access to ONTAP. So we're not talking about anything but other than management plane access. And so we're trying to strengthen the authentication by adding more factors to the authentication beyond the user ID password. So for example, I mean, everybody's heard about Equifax and what happened there. We don't know exactly how they got hacked, but we do know in the aftermath, some researchers came across their Venezuelan site, and their admin credentials were admin for user ID and password.
Is that a problem? I mean, that's what I use for all my things.
It can be problematic, yeah. I mean, so then somebody...
So they left the default password on their Netgear routers? Is that what they did?
This was on their system that was used to administer.
Oh, okay. So I heard it was like at first they were talking about the Apache exploit that got hit, right? So there was like some Apache exploit that's been around for months they hadn't patched.
Right.
So that was problem number one. And then later on it came out that they used admin.
Right. They found that in Venezuela. Yeah.
Yeah.
So anyway, we can see that in that case, well, that weak single-factor authentic credentials for single-factor authentication is a bad idea. But if you add more factors to the authentication, it's a very good idea.
Yeah, so I mean, single factor is one thing, and admin, we joke about that, but a lot of people don't bother with their passwords too much. But even if you have a strong password, it doesn't take long for password crackers to crack the passwords, right? So I mean, you can essentially crack a password, get access immediately. So with multi-factor authentication, that prevents that because you have to have something else to get you into the system.
That's right. So yeah, I mean, Juan doesn't like when I say this, but I'll say it anyway. The classic definition of two-factor authentication is what you have and what you know, right? So what you have is your, I don't know, it could be a token of some sort. It could be secure ID. It could be a certificate, a PKI certificate.
It could be your fingerprint.
Fingerprint, right? Yeah.
So Juan, why don't you like the what you have and what you know?
Mostly for the sales guys.
You don't like it because sales guys? That's your reasoning?
Because of sales. No, it's a very technical definition without just the add-on coloring to it, like what you have and what you know, like exactly what Dan is doing right now. It kind of gets lost. Okay, I have and I know something. I have a lot of things and I know a lot of things. So what does that mean in the context? So really, what you have is, like Dan has been saying, an RSA token or a CAC card for the government, or your fingerprint, whatever. These different things that you can potentially have, and then what you know, which is your username, password. And so when you put it in that aspect, it gives kind of the context. Just saying it is what you have and what you know doesn't paint the picture. And for somebody trying to explain this and trying to sell a solution, that doesn't really communicate the value prop that you ultimately end up getting.
Okay,
I'll nix that from my vocabulary then.
I still like it. I mean, that's valid, but it's also good to kind of simplify it so people understand that it's not hard to implement multi-factor authentication, and you get a lot of benefit out of it without having to do a lot of work up front. Because when I hear multi-factor authentication, if I don't know what it is, I'm thinking, man, that's a lot of work. All I want to do is do a password.
Right.
But if it's simply a password and like a key, then that's not so hard. Or like, for example, with website logins now, they're if you want to change your password, they've got to text you, to your phone number, or they can send you an email with a code, and then you got to go in and verify. Right. So these sorts of security measures, while they are a little extra work, are worth their weight in gold because you're preventing that access, root access to things just based on username and password, and that's really what we want to try to avoid when we're trying to set up our logins and that sort of thing.
Right.
The problem with username password is that the way that you generate your password typically is out of things that you know. So fundamentally, the seed into your own brain algorithm to actually generate the password that you're using is coming from things that are probably around in your environment that other people could take in, input, and run through the same set of logic mix. That fundamentally, we're all humans, so we have common ways that we think, and so you apply the same inputs that somebody else can look and see, okay, I know he works here, he lived here, and he did this, and he has this many kids, and these are their birthdays. Bada bing, bada boom, they can generate something that is probably your password.
Yeah, that's the social engineering aspect of it. Yeah. Actually, a buddy of mine works at Cisco. He's like in security there. His idea behind the whole social engineering and how to defeat it is to give wrong answers to things.
Oh, I do that all the time.
Well, yeah, I use passwords, for when they have security questions, I just use a password as the answer. So, I mean, it's not a good idea to use the actual answer.
Yeah, there you go. All right, so multi-factor authentications in ONTAP 9.3. So what sort of level of security are we getting out of this? Like, is there any sort of security standard that we're following with this?
I'm not aware that there's a FIPS rating for multi-factor authentication.
Not FIPS. Okay. We are for the web access. There's a standard way of doing the kind of the validation, and that's using the SAML.
Yeah, SAML, right?
Yep.
Yeah, security markup, security assertion markup language version 2.0.
Right,
and that's like the gold standard.
Yeah, and that's an OASIS-based standard, and it's widely adopted across the industry at this point. So it's something that's not out of the ordinary, and we're following a pretty good practice by making use of that.
Yeah, and fundamentally, the way that it works is that you try to log in to your system manager or unified manager account, and your web browser basically system manager goes, oh, wait a minute, I'm configured for multi-factor authentication. I need to redirect you to the identity provider, and so here's a new term. So IDP, identity provider. An identity provider basically is a separate box that handles this authentication for you. It's what's doing the multi-factor authentication. And it's also operating through your web browser. So we get redirected to the identity provider, and then you enter in your credentials. That identity provider then checks those credentials against what's logged in your AD, for example, and then says, okay, this looks good. You look good. You entered in all the factors that I've required you to enter, and then we'll go ahead and send you a SAML assertion, and that's just basically it'll send the web browser a SAML assertion. You can just think of that as a ticket or something, very high level. So now you have this ticket on your web browser.
Something I have.
Something.
Yes, it's something you have, but don't bring that up again.
And now you have this ticket, right? And you're trying to get into the system manager and unified manager ride. And it's like, okay, I bought my ticket. Please let me in. And so you go in. Now you get redirected back to your system manager or back to unified manager, and you say, okay, here's my ticket for access into the system. System manager and unified manager will validate that this is a valid ticket, and then we'll let you. Then it'll go, okay, punch your ticket and return back what's called a SAML token, and say basically, okay, you're good to go to ride this ride or any other ride that we have that's using this kind of mechanism. Which means that you log into System Manager. Now you're also logged into Unified Manager if you want to for the lifetime of that token.
Yep, something called single sign-on.
So what are we supporting in terms of identity providers currently?
Well, we've tested with two, Shibboleth IDP, which is like community-supported provider. As a matter of fact, Shibboleth is embedded in ONTAP for the service provider piece of ONTAP, and then also Active Directory Federated Services, which is Microsoft's. And those are the two that we've currently tested and we know work with ONTAP 9.3.
So no Red Hat IPA or anything along those lines?
They haven't been tested. They can be supported via PVR possibly.
Yeah, it's an open protocol, but the devil's always in the details.
Plus, ADFS can front end anything. You can connect anything through ADFS for an IDP. So
it's a lot of acronyms. Glenn, do you have a question?
Well, yeah, just a real quick one. I was wondering, I heard the word system manager very specifically in HTTP. Does that mean that we don't have any MFA options for the API?
For the API?
Yeah, ZAPI. If I'm programmatically communicating with the controller, is that still single factor?
Well, it's single factor for now. And right now, most of the applications that make use of ZAPI, including customer applications, aren't aware of SAML or IDPs or anything like that. And so, as such, we've made accommodations for the legacy authentication mechanisms to come into play.
So this is Unified Manager in addition to System Manager, right?
That's right.
Yeah, I don't want my question to imply that I think that's inherently broken. I just wanted to ask about it because I'm always carrying on about API access. So just to be thorough, and in case there's any listeners out there who are wondering, I think that answer's fine because really what we're talking about here is managing human beings, and any kind of programmatic access should be using SERP-based authentication anyways, something you can revoke.
So just so you know, Dan said yet, and then he looked at Juan like, are you going to beat me up now? So, who knows? It might be in the future. Who knows? Yeah,
most of the applications are beyond the scope of the things that Juan and I work on, but it doesn't mean those applications can't accommodate SAML and IDPs.
I'm sure if enough customers come waving money at us, we'll say, sure, why not?
Yeah, that could happen.
All right, so I mentioned that I was the lab manager for Dan. And a few times he had this set up and it broke System Manager. I couldn't get to anything. So if you could explain that scenario for us, Dan, and why that was happening. Because and honestly, this is a good way to approach it because we want to see what happens when that happens. So because people are going to run into it. So it'd be a good idea to just go ahead and nip that in the bud right now. So what was breaking there, Dan?
Well, there's a couple aspects. I mean, in the early goings, I was configuring Shibboleth IDP to interact with System Manager, and it's a fairly complex configuration on the IDP side, and there's a lot of ins and outs and number of XML files that you need to configure based on your setup, and that was not working, and that's why I needed console access, and that's why I asked you how to get to the console, because I needed console access to turn it off so I could continue working on it again. So once I got all that worked out, then I was legitimately turning up SAML auth with at System Manager, and then you weren't getting in because the back-end systems didn't have your identity defined in them. So there's that aspect wasn't something that was aberrant per se. I mean, I probably should have put your credentials in.
Well, beyond that, it also didn't have it in DNS, so I wasn't able to get to the identity provider because I was looking for a host name and it couldn't find it.
That's exactly right. Yeah,
right. So these are a few scenarios you may run into when you're setting this up. So have we simplified the setup at all, or is it pretty much like you have to edit some XML files manually?
Well, that's the way it works in Shibboleth for sure. I mean, you have to edit XML files. It's something not for the faint of heart, really.
So do we have any plans to set up something easy like a script to automate that so we can kind of simplify that whole process? Because, I mean, I've done this XML editing and this sort of configuration before. Kerberos is a good example of trying to set something up that has a lot of steps. Is there a way to automate this and make it easier right out of the box, right out of the gate? Just something that's off box, right? So you could set up something outside the gate. Yeah,
it's certainly possible. I mean, we would have to take inputs from like the metadata that comes out of the service provider, which is, what we call ONTAP at this point, and then populate that metadata into the proper XML files on Shibboleth. And yeah, it could definitely be done. I mean, anything can be scripted.
Okay. And this works with SSH as well. You're able to do multifactor on that as well?
Yes, that's right. With SSH, it does not make use of an identity provider, though. It's all locally defined accounts on ONTAP.
Oh, so you just basically the old public key stuff. You set up a public key and
right. Yep. There's a new there's a second authentication method that's part of the security login command. So you had we've always had authentication method, but now there's another mechanism for a second authentication mechanism.
Oh, okay, cool. So we added an additional step there. That's good. So I don't think we've touched on this before. I'd like to kind of cover it here. Is 9.3 adding any sort of cryptography or algorithms that are more secure, like your hashes, your MD5? Like we already have a set amount of algorithms and keys and hashes that are supported. So I'd like to cover those and what's already there. And does ONTAP 9.3 add any of that?
No, we're not adding any new encryption algorithms. What I can tell you, I'm not sure I mentioned the last time on the podcast whether or not I actually brought this up, but we are for NetApp Crypto Mod, which is used by NVE and the onboard key manager. We're currently submitted our paperwork to NIST, to National Institute of Standards and Technology, for the FIPS 140-2 Level 1 validation. We're waiting for the government basically to take a look and give us some feedback, but we're very well underway through that process. We have received algorithms, certificates for our algorithms, saying that they meet the standard, and so we're just kind of waiting for now the whole cryptographic module to finally be approved by the government.
Okay, so we're adding MFA to ONTAP 9.3. So that's all for security logins and getting into the system to be an admin. What sort of protections do we have for data that's already on the box or that's in flight currently today?
So we have we introduced in 9.1 NetApp volume encryption. I came on the podcast to talk about that, and we're making enhancements to NetApp volume encryption for ONTAP 9.3.
Okay, so let's recap what NetApp volume encryption is if people aren't familiar with it.
Sure. It's our software-based mechanism of encrypting your data when it hits disk. It actually is encrypted by the operating system and then actually goes to disk in an encrypted format. We're using AES-256 encryption. Actually, it's XTS AES-256 encryption, which means that basically on top of the normal AES-256 key, we add another tweak to make the data even more secure. We're actually using two AES-256 encryption keys to actually encrypt your data on disk. It's basically the standard for block encryption.
That's why the passkey is so long.
Yes, we have a lot of bits.
Don't forget that passkey.
And yeah, for the first release in 9.1 and in 9.2, we require you to use the onboard key manager. It's seamless, right? You just set up outside of the passphrase, the very long passphrase. You set that up, and then you can begin encrypting volumes, and those keys are automatically stored in on that onboard key manager and stored across the cluster, replicated and protected. And you'll never have access to those keys. They're always encrypted wherever they get stored, so you're good to go. But we've kind of what we've lacked is parity with our NSE solution. So our NSE solution, which is our self-encrypting drives, which are FIPS 140-2 level 2 validated. These are drives that are always doing the encryption for every bit and byte that goes into them. They've had the ability to support an external key manager, which means that you're able to separate the data from the actual keys that are protecting that data, which is great if somebody comes in and steals your controller. And one of the things that potentially can happen, especially with the new generation of controllers, is that these things are getting lighter and lighter. It's like picking up my 2-year-old now. Like I can throw him over my shoulder and carry him out the house, right? Like.
Yeah, but he's usually kicking and screaming, so that's harder to do than an SSD disk. But anyway, continue.
Yeah. So in doing so, you kind of want to separate. It's best practice. It's the best security practice. Really separate what you're encrypting from where the keys are stored. The benefit of doing it all in box, it's easy to manage, it's low cost. We see, large and small customers kind of prefer that simplicity. But when you have that kind of simplicity, you are giving up something, and I want to be absolutely clear and upfront with that. So with ONTAP 9.3, we brought in the ability to do an external key manager, put in an external key manager, and use NVE as well. So now you can have NSE with onboard or external key management, and NVE with onboard and external key management. And so with Flash in particular, we have this great new technology. It's fast, right? It makes the systems perform better, and it's incorporated in that way. But Flash brings in some new attack vectors. It's like the North. It's like Pepperidge Farms. It remembers, right? It has this thing called wear leveling in it. And basically, you can say, "Hey, you write a block of data, and you tell it to overwrite it. Well, that drive's going to do what it wants to do. It's not going to listen to you. It might tell you that, yeah, I overwrit it, but it'll pick a different location on that disk to drive. So, whenever you're writing to a flash device, first of all, you need to make sure that it's encrypted. But if you really want to validate that something was completely deleted off that drive, how do you make sure? Well, really, what you were then looking for are cryptographic ways to kind of invalidate that data. And you want to make sure that it's been blasted from existence. And the best way to do that is to make sure that you know where your keys are stored and exactly where they're stored. And this is why you would then, in theory, leverage an external key manager.
You'd also use it because you already have one, right?
Right, and you would have potentially multiple applications that are using this external key manager. Really, it's one of the benefits is having that centralized key management structure. The other one is that if you do have, if you're not a one-man army running around your entire company doing everything, you can say, hey, I'm going to manage the storage, and these guys are going to manage the security, and so it's going to be their fault if anything goes wrong, and we become the next Equifax. So you kind of separate that out for yourself and just say, hey, I'm fine punting these responsibilities to these guys and go from there. The other benefit is that you are actually able to get key managers, which are already FIPS validated, and to level even 3. So if that's something that you're looking for to get that kind of security around the key management portion, which it's the keys to your kingdom, something that you can do with an external key manager.
Okay. So anything else we're adding in ONTAP 9.3 for security, or is that about it?
For security...
wait, I actually know one. So the recrypt, decrypt, are we adding part of that?
So what you will be able to do in ONTAP 9.3 is to be able to cycle the keys on an encrypted volume in place, meaning that for that specific use case, and it's a very good use case. So you want to have either you or your security team define a lifetime for a key to basically encrypt the data, because time is, ultimately what's going to get us all in the end, one way or the other. And that's true for your data and the keys that are used to protect it. So periodically you want to define a cycle or a set of, basically a cadence of where you change out the keys for you that are used to encrypt your volumes. And now you can do that with a command that basically lets you do it in place. So you don't need to have the extra space on that same aggr or on a different aggregate for the vol move. Now we will encrypt in place, meaning that we'll just cycle out. We'll encrypt block by block, keep track of the entire volume content, and then basically once it's done, we delete the old key, and we go from and you go from there. Now you have a new key protecting that volume, and you're following best practice key management lifecycle kind of stuff.
Okay, so let's talk about some scenarios with MVE. So, people ask these questions sometimes and they come up, and it'd be good to address them now. So let's say I have a volume that's been encrypted with MVE, and I pull a drive. Can I get the data from that drive?
You can get whatever data isn't encrypted with NVE, but your data volumes are, if they're all encrypted with NVE, you're good. The drive wouldn't have the keys required to unencrypt it. And that's with the external key manager or the onboard key manager.
Okay, cool. So essentially I get the benefits of NSC without having to encrypt everything.
Right.
So what is what benefits do I get out of using both NSC and NVE together?
So you get this ability to basically encrypt your data twice and do it with all your efficiencies. So that's one of the basic and greatest value propositions of why you want to do encryption on your storage arrays, that we're able to apply everything that we do, and especially in our flash fast systems, inline. So you get your compression, you do duplication, you get your compaction. And then we're also encrypting your data, oh, by the way, once it hits the disk, and all by preserving your performance. So the reason that you want to use NVE plus NSC is that there's this what is called a what's called a capability package that the NSA publishes. So the National Security Agency kind of publishes, and one of the recommendations, and specifically for storing data at rest, is to basically have the ability to store data encrypted with two different mechanisms. And really what they want is two different vendors to provide those encryption methods. We source our NSC drives. They come FIPS validated from the vendor. So it's the vendor that we get them from already has gone through that process, and they create the encryption algorithms, and they test them, and they get validated. And then we provide NVE, and we're doing that through going through the FIPS validation process ourselves. So really what we're able to do is provide this kind of two layers of encryption. And really I think I mentioned this last time, it's called the Swiss cheese approach. So if for whatever reason one level fails, you have that other level to kind of back it up, layer to back it up. And so you were able to do that with natively with our solution, and I have not seen any other solution out there basically have a way to do it in software, and as well as a way to do it with hardware as well, like we can with our ONTAP engineered systems.
So you wouldn't call
Can we
that
use
belt
two
and
different
suspenders?
key managers in that scenario?
So for the cluster, we would have one single key manager that we're paired with.
Okay.
So one key manager for both NSC and NVE?
Correct. The cluster would just send all the keys that it requires to a key management or a cluster of key management servers, and basically it would request those keys when it needed them accordingly.
Yeah, that's interesting. That's an interesting use case of combining the two and really creating this. Just you're not getting in there unless you have these keys. It's just not going to happen.
Exactly.
There's too much entropy at that point.
Oh, yes.
So I'd like to mention 9.2 offered NVE support for flex groups, right? So we added that.
Yeah.
So flex group volumes are now able to be encrypted as well. So if you have a large bucket of data that you want to encrypt, that's something to look into. And then with 9.3, you're able to do it off box as well as on box.
Exactly. And, well, if we're on the subject of 9.2, in 9.2 we introduced Online Certificate Status Protocol, OCSP, for validating whether or not your certificate, your whatever's connecting to your system and actually has a valid certificate.
I don't think we ever covered that. Let's go into that a little bit.
Yeah. So, you have a certificate. You have a client that's using a certificate, and that's how it authenticates itself to you. And it's also how it's encrypting the data between you and, from it and ONTAP. Periodically, these systems can be compromised, right? And so that certificate's still sitting out there. Well, it's possible for the certificate authority, the person who granted the certificate, to say, hey, that certificate's no longer valid. What OCSP does is basically allows us to check the certificate, go to the certificate authority and say, hey, does this guy still have a license? Basically, is he licensed to operate? And then he'll say yes or no, and then we'll allow the connection or not. At a very high level, that's how it kind of works. If it does require your certificate to be generated in a particular manner, basically, it needs to tell us who do we go ask if you're valid or not, and who was your granting authority. And then if that information is there, we'll go look for it. If that information is not there, we'll just proceed with the connection because we can't do any better. But if that information is there and for whatever reason we don't get a response or the response comes back obviously negative or anything but okay, we do not allow the connection to go through. And that's fundamentally how OCSP is intended to work.
Does it support OSCP stapling?
No, just straight up OCSP.
Okay, so that would also apply for let's say somebody gets let go, and it would I guess periodically query to see employees that have had their accounts retired, right? Potentially.
So so you could use it for a variety of services, and one of those services is WebAuth or KMIP. Configuring to the external key manager, LDAP connectivity, all that stuff. You can turn it on or off for each one of those individual protocols, or you can turn it on for all protocols. It just depends. But just be aware that if you're operating with an invalid certificate and you've kind of been just happy about the way the system is working, and all of a sudden you turn this thing on, it might spit out information that might make you go, oh, maybe this thing wasn't working like I thought it was. So like with anything, especially security, that will limit the connections going in, just realize that that's something that potentially could be a side effect. It'll tell you what's wrong with your system. It'll tell you clearly that, hey, something wasn't properly configured. But just to be aware.
Okay. And the performance impact is pretty minimal because we're doing offloading to the AES-NI portion of the processors, right?
For this, it's not really required. It's just more about checking.
Well, I mean for NVE.
For NVE, yes.
Sorry.
Yeah. For NVE. We're, all our new platforms contain the Intel AES-NI offload. For ONTAP Select, the minimum processor requirement actually basically guarantees that you have a platform capable of running NetApp volume encryption. So all ONTAP Select basically is grandfathered into using NetApp volume encryption. And for MetroCluster, it's the only way to do encryption in MetroCluster as well. So if you have that synchronous replication solution, because of the way the standard is for self-encrypting drives, they basically dictated that these drives only have 2 control channels. Well, that doesn't work. That works great for an HA pair, but it doesn't work great for a MetroCluster case where now you have 2 nodes on each site, and basically either 4 people can have control of this drive. When you only have 2 control channels, you're basically limited to an HA pair. So self-encrypting drives for MetroCluster just fundamentally don't work because of the architecture of MetroCluster and the drives that kind of no mix and match, like cheese and my peanut butter.
So how does SnapMirror work with NVE?
So SnapMirror. So NVE allows you to be agnostic of actually the encryption that's happening on your system. Everything gets encrypted and every volume gets its own unique key, but anything running on top of it has no idea that it's encrypted. So you can encrypt the source and not the destination. You could have NVE encrypting your source and have it be replicated to an NSC cluster. That portion you can manage on your own. Basically, we'll do a decrypt on the way back out. Once it leaves the disk and goes through our RAID layer, the data is unencrypted. That's why nobody knows that it's encrypted when they're using it. And basically, that also allows us to apply our storage efficiency features at the waffle layer. And so a SnapMirror would be one of those applications above, would not know that it's encrypted, would send it over to the destination, and then the destination can decide to encrypt it or not encrypt it or whatever else you want to do.
So that's something to look out for, right? If you're looking at trying to do end-to-end encryption, if you snap mirror it out while it's going over that wire, it's not technically encrypted anymore at that point, right?
Right. Correct.
Are there any sort of ways around that, workarounds, like maybe using some sort of IPsec or anything like along those lines? Or
Well, the best practice is to basically terminate a VPN there to your to the ports that are doing your snap mirror. Another best practice, in particular for snap mirror, this brings into my networking hat of the side, is to limit basically the number of ports that you're doing snap mirror on by using IP spaces, which is our network virtualization technology. Basically, you get a network stack specifically just for doing replication. It's not going to expose any of your other services, and you know what's happening on those ports is purely just replication of data. So you a couple IP spaces with this network virtualization just purely for replication on top of a VPN tunnel between your source and your destination, and then you're good to go.
are these best practices documented anywhere?
These best practices should be somewhat documented in TR 4182. That's the network I forgot what's Ethernet best practices document.
So you have a blog, right?
I have a security blog. Yes.
Maybe you should document them there.
I should probably document them there.
What is your blog anyway, Juan?
It's a security brute squad at blogspot.com.
Okay, so securitybbrutesquad.blogspot.com.
Yes.
And I expect to see those best practices there forthwith.
All right.
All right. So we've covered the at-rest encryption, and we've talked a little bit about snap mirror encryption, trying to get it encrypted over the wire by using VPNs and best practices. In addition to the AES-NI offloading for MVE, we also offer that for Kerberos 5P, which is privacy for Kerberos over NFS. That allows you to do Kerberos encrypted packets end-to-end. That is offloaded as well in AES-NI and 9.2. Greatly improves the performance for Kerberos. You get basically one-to-one performance in that case. Additionally, SMB signing and sealing for CIFS is also in ONTAP 9.1 for offloading to AES-NI. So if you're interested in encrypting your SMB packets, you can do that. And as far as fiber channel iSCSI goes, I have no idea. Do you guys know?
A fiber channel in and of itself doesn't have much.
And then iSCSI has CHAP or whatever you want to use there, right?
CHAP. You can use CHAP.
So I guess I did have a little bit of an idea there.
Yeah.
I'd just throw on there anecdotally that Fiber Channel has zoning, right? So it's physical
yeah,
security.
zoning. That's right.
Yeah, well, that's physical. Like that's old school, right?
It's exactly. It's physical security. It's a different way of going about it.
Yeah.
I've been in learn mode the whole time.
It's good. You need to secure your containers.
Every once in a while, gotta figure out something new, right?
Yeah. No, so I went to Black Hat this past year, the conference, and one of the things that was brought up was that we have all these industrial systems available in the wild. And an industrial system, typically, if you're going into a manufacturing plant, you're supposed to wear a hard hat and walk through. Well, you have industrial systems available out there in the world today that are just there that you could just walk through, in particular, a car wash. A car wash is an industrial system, right? You have this huge piece of machinery. And in particular to the MFA discussion, a lot of these things are connected to the internet. And a lot of these things have a built-in engineering account that isn't disabled at all. And so what researchers were able to find out was, A, that they could hack into one of these systems pretty easily because the credentials were never changed. There was no multi-factor authentication.
Admin.
And
admin. Or SMB1 on our printers.
And that basically that anything that wasn't regulated by a physical mechanism could be broken with firmware or software changes. So basically, they were able to get a car wash door to come down repeatedly onto a dummy, onto a car, onto anything that they basically wanted to destroy. So it's kind of very, very, very cool and very pertinent to some of the stuff that we're doing.
Yeah, I'm terrified of all this like new wave of internet connected everything because I just look at all of it going, there's no way that HVAC manufacturer has got the right security staff in place. There's no way that they've got a firmware patching process. You're just asking me to connect a botnet in my house, and I'm not going to do it.
Right.
Have you guys seen the latest season of Silicon Valley?
Yes. With the refrigerator.
With the refrigerator, yeah. They hacked the refrigerator. I won't go into any more detail because it's offensive to some people. To me, it's hilarious. But yeah, so they hack a refrigerator and put a message on there, and it's pretty funny.
Yeah, it's
so
pretty good.
it's just latest season of Silicon Valley, always pertinent in the tech field. Last season was about storage industry. That was pretty interesting.
Yeah.
So, all right. Cool.
Next season will be all about patching your software because apparently we still can't seem to learn that as an industry.
That's never going to happen, I don't think. I don't think anyone's ever going to learn that lesson, no matter how many times it happens. We're seeing it over and over again. Okay, Dan, Juan, thanks so much for joining us today. If anyone wanted to get in touch with you on social media, how would they do that, Juan?
You could hit me up on Twitter at Juan_M_Mojica.com. And yes, there are other Juan Mojicas, and you want that one.
Why didn't you take the Twitter handle I'm the Juan?
Wouldn't have been my first
Asking
choice.
the real questions.
Obi-Wan. Come on, man.
I'm pretty sure some of those are already taken.
They may have been already taken. Dan, do you have any social media presence that you want to tout here?
I do have a Twitter account, Dan_Tulledge.
Okay, cool. We'll put that into the show notes and post it on the blog. Thanks so much for joining us today and talking to us about the new ONTAP 9.3 security enhancements. All right, that music tells me it's time to go. If you'd like to get in touch with us, send us an email to podcast@netapp.com or send us a tweet at NetApp. As always, if you'd like to subscribe, find us on iTunes, SoundCloud, and Stitcher, or via TechOnTapPodcast.com. If you like the show today, leave us a review. On behalf of the entire Tech on Tap podcast team, I'd like to thank the security squad, Juan Mojica and Dan Tulledge, for joining us today. Thanks for listening, super best friends of security.
Thanks, Justin.
So, Insight, we're going to hear about some security things. Are you guys going to be hacking phones while you're there? Are you going to be like breaking into people's Internet of Things devices?
We can't talk about that right now.
I want to talk about it.
Yes, Justin.
I'm just
That's
gonna-
what security people do is just hack on their phones.
They do!
I'm just going to set up a whole bunch of hotspots. And people are going to wonder what the heck happened.
Pineapples?
To the internet. Yeah, exactly.
Bunch of pineapples?
Yeah.
Yeah, there you go.